Hello, everybody. This is Miss Abney. We are here for topic 2, lesson 3, example 2. We have a nice graph. So in this example, we're going to relate factors to zeros of a function. So we're going to see how the factors that we get relate to our graph, because we've been looking at the graph up to this point. We've been looking at key features of the graph, and the zeros of the graph are key to our parabola. We need to know where we cross the x-intercept. So I did mention before that we have different names for the x-intercept when we're looking at the equations. So we're going to have the zeros of the graph, which basically means when y equals 0. So if I ask you, what are the zeros of my graph? We're going to look at when y is equal to 0, what my x values are. And if you remember, y equals 0 on the x-axis. All right, the second way I could say this are, what are the roots of my function? And again, the roots are what basically keep us grounded. And if we're thinking of the x-axis as the ground, and this is below, this is when the roots start, when the graph crosses the x-axis. So that's another way I could say the roots of the function. I can also say, what are my solutions to this? And you'll see in later examples that we want to get to that 0. We want our output to be 0 to find the solutions of a quadratic. So these are different ways that we could describe the x-intercept. So the graph shows the function defined by x squared plus 2x minus 8. How do these zeros of the function, again, where it crosses the x-axis, relate to the factor of the expression x squared plus 2x minus 8? There is last example. Let's throw this example up on my smart notebook. And the graph shows, I just read this. So let's factor this out. X squared plus 2x minus 8. Two factors that multiply to give me negative 8. Let's see, 1 and negative 8. Or we could change the sign there. I like how I kept the signs the same. Just erase that. All right, and then we have 4 and negative 2, or 2 and negative 4. See, 1, 2, 3 does not go into 8. We already covered 4, 5, 6, and 7 do not go into 8. So these are the only factors that we have that go into 8. Add them across. And we get here negative 7. Here we get 7. Here we get 2. And here we get negative 2. My c in this case is a positive 2. So these are the factors that we are working with. Sorry about that alarm. So I'm looking at x plus 4 and x minus 2. Now I'm going to look at these points. They give me this point and this point, my zeros. So what I'm going to do is I'm going to test these points out in my function here. So I'm going to plug in the negative 4. And what I get in this factor, I get the value of 0. And this factor, I get the value of negative 6. 0 times any value is going to give us 0. All right, so we see that when we plug in our x-intercept point, we get 0. Let's try the other one. I believe it was 2. 2 plus 4, 2 minus 2. So this right here becomes 6. This right here is the factor 0. 6 times 0 again is 0. So anytime we plug in a value into my factored form, we at least get one factor that's equal to 0, and that makes our whole solution equal to 0, which it should be because our y's are 0, and that's what the output should come out to be, is 0. But this idea comes into play when we start looking for the solutions of our quadratic, which will be the next example. So again, here is them doing the work. They do the factoring, and they have the x equals 2, they substitute it in, and they find that we have zeros. So the factor of x plus 4 and x minus 2 are related to the zeros, x equals -4 and x equals 2, since each of the zeros makes one of the factors 0. All right, there's your try it. They want you to, again, identify the x-intercepts and do the factoring and see how it relates. Spoiler alert, you should get out 0 when you plug in your x-intercept values. All right, so I will see you guys in the next video, and if I don't, I hope you guys have a wonderful day.